in this problem, we're going to do the same thing as we did before, but there is an important feature in this problem, and that is that the marginal profit is actually negative for a good chunk of the time. So that means in this period, the profit is still decreasing as the marginal profit is negative. So let's find out what will the profit be if this is the marginal profit. What would the marginal profit be whenever we're selling 1,000 units? Well, we want to find then the profit, since x is in thousands of units, would be just x equals to 1. That corresponds to 1,000 units. And that would be then the integral from 0 to 1 of the marginal profit, which is going to be x squared minus x minus 2 dx. And then we take an antiderivative here, and we get a third of x cubed minus a half of x squared, then minus 2. And we oops, I forgot something, 2x. And then we evaluate that from 0 to 1. And so what do we get? Well, whenever we plug in 1, we get a third minus a half minus 2, and then this would be the antiderivative evaluated at 1, and then minus the antiderivative evaluated at 0, which would give you 0. So that would be a third minus a half is going to be negative 1/6, and then negative 1/6 and 2, you could write it as negative 2/16 if you want, which looks ugly to me, but this would be in thousands of dollars. So if in your case you would write it in red numbers, and let's write it in terms approximately in that case then at negative 2,166 with 67 cents. So this is what makes sense in terms of money. This doesn't make any sense. We're talking about money here, so this would be the amount. Okay, so now let's look at what happens whenever we sell 3,500. So that would be the profit at 3.5. Why did I choose that number? I don't know. It's going to be ugly to evaluate it, but I'll just give you the answer. So here you would do the same thing we did, except so you calculate your antiderivative in the same way, and then minus a half of x squared. So just copy the same thing, and now the difference is we're going to evaluate it between 0 and 3.5, and that gives us, so it gives us 1,166 with 67 cents. So yes, I cheated there. I put it on the calculator. So what this is telling us is that at first you see how the profit, since it's going to be the area, it's going to be the area, in this case under the curve, but it's going to have a negative sign as you are on the negative side of the or below the x-axis, or the negative side of the y-axis. But as you go to 3.5, which would be somewhere in the middle here, if my line would be straight, you keep going negative for a while, and then it becomes positive, and at some point the accumulated area becomes 0. That point, when the profit is 0, is the equilibrium point. So then you pass that and your profit becomes positive. So you can see how at first your profit is not, or your revenue is not big enough to overcome your cost. So you have a negative profit for a while because your marginal profit is on the negative side. So the area under the curve is negative. Then it becomes positive, but you still have an accumulated negative profit going on until you get to a point perhaps around here where the area of the positive area overcomes this negative area, and you get that the profit at some point around here is 0. As I said, that's your equilibrium point, and then past that point, your the area under the curve, if you consider this one negative and this one positive, becomes indeed positive, and that's what you want. You want your profit to be positive. So this is a nice example that represents a little more the situation where you actually have an equilibrium point. In the previous example I did, it was always positive. It started at 0 as if there are no fixed costs, and that's perhaps a little unrealistic. But anyways, if you have any questions regarding this problem, let me know or write your comments in the comment section. Thank you so much for watching.